I wanted to dedicate a short video to looking at how web applications work and what components are involved. This is going to help us understand how our attacks and payloads are delivered, handled, and ultimately executed. Understanding how web applications work, and if you have time, then building one yourself, is going to be the thing that keeps on giving when you're trying to troubleshoot some behavior or get a payload to work. It's okay to start with fuzzing and sending known payloads, but as you develop your skills, you're going to want to move on to more complex attacks by chaining things together or crafting novel payloads that work in a specific situation. And it's okay if you don't absorb everything all at once, just keep at it and over time everything will click into place. So let's take a look. If we take a look at most web applications from a high level, they use a general architecture that looks something like this, and this is often called the client-server architecture. We have a front end, which is your browser, and a back end that consists of the application server and usually databases or other components that we'll get into later on. But most applications will have an application server and a database. Now, there are different types of architecture, but generally speaking, they are still a variation of this concept of front end and back end, or client and server. Even with things like microservices, in this case, we just have lots of back-end services instead of a single application server, and we still see the same request-response model going from the front end to the back end. And just a note on the word architecture. I think this can be a little bit ambiguous for a lot of people, but architecture generally describes the major components of a system and their relationship or how they interact with each other. And that's it. Think of it as a blueprint and nothing more. So no matter how complex the application is, you can always divide it like this and separate components to make them easier to digest. And one last thing to remember is that the word server is often used interchangeably between the web server software, the application server, and the piece of metal that is the physical server itself. So the backend is often split into these three components and data flows between them. So as an HTTP request comes in, it's handled by the web server. If the request is for a static asset like an image, it will just respond with that, and it also deals with parsing HTTP and can handle concurrent requests. If an HTTP request needs to be passed to the application for processing, then it's sent to the application server, and there is a component in here that passes that HTTP string into something that the application code can ingest and deal with. And once it returns something, for example, let's say it returns an array, the application server will then convert that to HTTP and pass it back to the web server. And we don't really need to go this deep, but when the application is passing data to the code and back, they use a communication protocol so that they can both understand each other. So to quickly recap and go over the responsibilities of these components, the web server is primarily responsible for handling HTTP requests from clients, and its main role includes things like receiving HTTP requests, serving static content, and forwarding requests to the application server. The application server is where the core business logic of the application resides, and it handles more complex processing and interactions. It can also do things like decoding request data, so whilst the web server might handle basic decoding like URL decoding, the application server often handles more complex data decoding, so things like parsing JSON, XML, processing form data, or handling multi-part data from file uploads. The application server also executes the application logic, so this is where the bulk of the processing happens, and the application server runs the code needed to perform actions based on the request, such as querying databases, processing data, and generating dynamic content. And of course, after processing, the application sends responses back to the web server, which are then forwarded to the clients. So let's take a closer look at the front end as well. We have three main components at work here: HTML, CSS, and JavaScript. And we'll take a closer look at these in a moment, but first I want to talk about the DOM. On the left here, we have our page that's being rendered by the browser, and of course we can right-click and view source or hit Ctrl-Shift-C and inspect the page, and on the right we have a DOM representation of this. Now, the DOM is a programming interface provided by the browser for web documents. It represents the page so that we can change the document structure, style, and content, and the DOM represents the document as nodes and objects. This way, programming languages like JavaScript can interact with the page. So if we update the DOM, our page updates, and if we update the page, the DOM updates. They are always in sync, and this is handled for us by the browser. So let's take a closer look at HTML, CSS, and JavaScript. So briefly looking at each of these, they all play an important role from the perspective of a working application and also a security perspective. Now, I want to just talk briefly about people's attitudes towards the front end, especially in security. The front end is really important, and there's a tendency in the securities community to be snobby or ignorant about things like JavaScript and CSS and front-end frameworks. Now, don't fall into this trap, and if you think that CSS isn't important, then you can go ahead and Google Gareth Hayes blind CSS exfiltration, and you'll see some awesome attacks. Gareth's a researcher at Portswigger and always publishes really great work on things like escaping JavaScript sandboxes. In the past, I've also found an application where I could inject CSS and steal PIN numbers, for example. Everything is important, so even if we don't like a particular technology or we feel that it's easy and straightforward, we still need to be on the ball. The front end is also becoming more complex with modern frameworks like React and Angular and Vue, and we need to understand these so that we can find and exploit vulnerabilities. So let's take a brief look at front-end frameworks. Front-end frameworks are powerful tools in modern web development that help us build complex, interactive, and responsive web applications. Generally, they provide a structured way to organize code and have collections of pre-written components and tools to handle common tasks like routing, state management, and interaction with back-end services. So some of the most widely used front-end frameworks include React, which was developed by Facebook. It introduces the concept of the virtual DOM to optimize rendering and updates and focuses on building UI components. We often see it used with additional libraries for things like state management with Redux and routing. Next is Angular, which was developed by Google. So Angular is a framework that includes built-in services for routing, forms, and all sorts of other things. It uses TypeScript, which is a superset of JavaScript. And there are others like Vue, etc., etc., so you can go and look them up if you want to. Now, before we wrap up, let's take a look at some other common components that we might run into and briefly introduce them. So first up we have load balancers, and the purpose of these is to distribute incoming network traffic across multiple servers to ensure that no single server bears too much demand. And by spreading the load balancers reduce the individual server load and improve the responsiveness and availability of applications. So they're obviously used in high-traffic websites and within enterprise environments to enhance the scalability and reliability of web applications. Databases, of course, are used to store, retrieve, and manage data persistently. Databases can be relational, like MySQL, Postgres, Oracle, or non-relational, like MongoDB, Cassandra, or Redis. Almost all web applications that need to maintain user data, transactional information, product data, all use databases. Next, we have web application firewalls, and of course these are designed to protect web applications by filtering and monitoring HTTP traffic between the web application and the internet. They do protect against common attacks, so things like SQL injection, cross-site scripting, file inclusion, and of course deployed in front of the server to act like a shield to protect from malicious payloads. Next, we have content delivery networks, or CDNs, and these store cached versions of content in multiple geographical locations. And these are points of presence, also known as POPs, and they serve content to users from the nearest location. So, of course, they're usually used for serving static content like images, style sheets, JavaScript, videos, documents, and things like this, non-dynamic content to reduce the load on the original server and speed up content delivery. Next, we have API gateways, and we won't be covering APIs in too much detail in this course, but of course you can check out the practical API hacking course. But the purpose of API gateways are to manage, deliver, and secure APIs. And API gateways often handle rate limiting, caching, authentication, CORS, and service orchestration. They serve as a reverse proxy to accept all API calls, aggregate the various services required to fulfill them, and then return the appropriate results. And finally, we have reverse proxies, and these are used to retrieve resources on behalf of a client from one or more servers. These resources are then returned to the client as if they had originated from the reverse proxy itself. They can help with load balancing, web acceleration, security by obfuscating the backend services, and caching static content. Alright, that's it for this video, and I will see you in the next one.